Hi, this video is presented by Group 12, summarizing the article. Titled, A Systematic Mapping Study for Ensemble Classification Methods in Cardiovascular Disease, written by Mohammed Hosni et al. Let's start by uncovering the objectives of this study. The first objective is to investigate the application of ensemble classification methods in cardiovascular disease, CVD, research through a systematic mapping study, SMS. Secondly, the researchers aim to identify, classify, and analyze relevant studies in the literature to provide insights for future research. This study seeks to enhance the understanding of how ensemble classification methods are currently used in CVD research. Now, let's have a brief introduction to the article. The use of machine learning or ML techniques in medical decision support systems is on the rise. In particular, ML helps doctors analyze medical data for the early detection of cardiovascular disease, CVD, which is crucial for effective treatment and improving survival rates. However, accurately diagnosing CVD with a single classification technique can be challenging. Ensemble ML methods address this challenge by combining multiple classifiers, thereby improving diagnostic accuracy. These methods aggregate outputs from various models, producing more stable and reliable predictions than any single technique. Now let's move on to the methodology. The methodology used comprised of 5 main steps. Firstly, defining the mapping questions. Secondly, searching for candidate papers. Thirdly, screening the potential papers. Fourthly, keywording of abstracts. Lastly, data extraction and mapping the findings. The study began by identifying key research questions. These questions covered publication trends, medical tasks investigated, types of empirical and research study, single techniques used, type of combiners used, ensemble methods, evaluation framework, tools used, and parameter optimization of techniques. All 9 mapping questions aimed at categorizing and exploring various aspects of ensemble methods in CVD classification. Next, a comprehensive search strategy was developed, which involved defining search strings and choosing literature resources to find relevant studies. The researcher conducted extensive searches in databases like IEEE Xplore, ACM Digital Library, PubMed, and Scopus using specific keywords related to ensemble methods and CVD. Following the search strategy, the next step involved the study selection. A total of 351 relevant studies that met specific inclusion and exclusion criteria were chosen. All these studies focused on the use of ensemble methods in diagnosing cardiovascular disease. Subsequently, the data was extracted from the selected studies using a predetermined format to address the 9 mapping questions. This process was conducted by 7 researchers to ensure the accuracy of the data. The data was then synthesized using the vote counting method and narrative synthesis, with charts and tables enhancing the display of findings. The research also addressed 2 main threats to validity. Study selection bias, which was mitigated by a broad search string and involvement of multiple researchers. Next, data extraction bias, minimized by validation and discussion among researchers. Now, let's move on to results and discussions. The overview of the study selection process. The study reviewed classification approaches for cardiovascular diseases, CDVs, by searching 69,336 articles from 2000 to 2019 across 4 digital repositories. There are 9 mapping questions examined in this study. MQ1 aimed to identify trends and sources in research on ensemble classification techniques for CVDs. The study found increased interest in this area over the past 8 years, highlighting useful sources for future research. MQ2 aimed to list medical tasks addressed by the research. Prognosis was the second most studied with 60 articles, while fewer than 12 papers covered other tasks. The study urges further research into applying ensemble classification methods to these areas. MQ3 aimed to categorize the selected publications based on the types of research and empirical work. MQ3 evaluated ensemble categorization strategies through experiments but found no empirical support. Real-world validation in settings like clinics and hospitals is needed to enhance practical relevance. MQ4 aimed to identify the most commonly developed ensemble classification techniques in the selected publications. In MQ4, most publications preferred homogeneous ensemble techniques, combining a single classifier with a meta-ensemble. Heterogeneous approaches, which require more careful selection of ensemble members, received less attention. Developing frameworks for selecting suitable classifiers in heterogeneous ensembles is crucial for improving reliability. MQ5 aimed to enumerate the distinct procedures involved in creating ensemble classification strategies for cardiovascular diseases, CVDs. The study identified 12 methods for homogeneous and 11 for heterogeneous ensembles, with DT, ANN, BC, and SVM most frequently used. KNN, though less studied, showed accurate results. Further research on KNN and hybrid techniques with fuzzy logic is recommended. MQ6 aimed to identify the rules used to generate the final decision in ensemble classification methods. Various combination rules were used for final decisions in ensemble classification methods, but Board Accounting, Dempster-Shafer, fuzzy combination, and the knowledge behavior space algorithm warrant further investigation. MQ7 aimed to identify commonly used performance metrics, datasets, and validation techniques for developing and assessing ensemble classification systems. Studies on cardiovascular diseases use datasets from UCI Repository and PhysioBank. However, many did not sufficiently preprocess their data. More attention to preprocessing can reduce costs, improve interpretability, and enhance predictive capability of ensemble methods. MQ8 aimed to identify the tools and methods scholars use to construct their ensemble classification methods. Strong software development skills are crucial for implementing ML algorithms. Using existing ML tools, like Weka, Python libraries, and our software, can save time and ensure reliability in research on ensemble classification methods for CVDs. MQ9 investigates parameter settings and optimization techniques for individual machine learning techniques used in constructing ensembles. In 100 of 351 studies, parameter settings for constructing ensemble methods were addressed. Optimizing these settings based on the dataset improves classifier accuracy, with techniques like grid search, PSO, GA, or ANTC recommended for better results. Let's move to the last part of our video. To conclude, ensemble classification approaches improve the accuracy and reliability of CVD diagnosis, offering superior performance compared to single classifier models. Further development and optimization of these technologies are required to fully realize their potential and successfully incorporate them into clinical practice for better patient outcomes. Thanks for watching.